So in this video, what I'm going to introduce you to are our fundamental trigonometry identities and how we are going to use those fundamental identities to prove other identities are true. So along the way, if you need to pause the video to take in your notes, please do so. I'm going to break the lesson into several different videos, so to keep them a little shorter. So here are the trigonometry identities that we are going to be dealing with. When we look at these are reciprocal identities because we're just flipping them over. Our quotient identities. Tangent can be written as sine theta over cosine theta. That's a big one. But if we flip it around, the reciprocal of that is cotangent theta is cosine theta over sine theta. Our Pythagorean identities, these are big. These three right here in the middle are really big. Another way of expressing these, instead of saying sine squared theta or sine squared x plus cosine squared x equals 1, a lot of times what we'll do is we're going to say cosine squared theta equals 1 minus sine squared theta, or we're going to say sine squared theta equals 1 minus cosine squared theta. We're going to use a little algebra and we can move stuff around. We can do the same thing here with our tangent squared theta and our secant squared. So, excuse me, we can say secant squared theta minus tangent squared theta equals 1. And again here, cosecant squared theta minus cotangent squared theta equals 1. Those are all true. Another way to write all of these, we can move them all around. Now these even and odd identities, all this means is in this sine of negative theta equals negative sine theta, if you plug a negative value into the sine function, the entire value of the function is negative. Plug in a negative, what I get out is a negative. That means this is an odd function. Cosecant is also odd because it's the reciprocal of sine. I plug in a negative value, I'm going to get out a negative value. That's an odd function. A cosine function, however, is what we call an even function. Because if I take out all the x's and replace them with, and I plug in negative values, I'm going to get out a positive value. So my cosine and my secant are even functions. And tangent is again odd. Tangent and cotangent are odd because if I plug in negative values, the entire function I get out is negative. So be aware, like I've already showed you, we're going to be using alternate forms of some of these identities. What I mean by that, instead of saying sine squared theta plus cosine squared theta equals 1, a lot of times we're going to say cosine squared theta equals 1 minus sine squared theta, or we'll say sine squared theta equals 1 minus cosine squared theta, either of those. Alrighty, so what I'd like you to do is go ahead and pause this video, and there are some 10 blanks for you to fill in using your trig identities. Now, your answers for 4 and 10 might be a little different than mine. You're just going to find different values for 1 in each of those. So go ahead and hit pause and jump onto that. Alrighty, welcome back. Let's see what you got. So for the first 6, we just wrote down some of these identities. If you had any questions on how I got these, please come in on Wednesday night or the next time we meet, and we will cover them. Number 6 was just about writing them down as fractions. The last 4 look like this. Notice number 10, I just did a different value than I did for number 4. Boom. All right, let's do some examples now. What we want to do is we want to simplify our statements. We want as few trig functions in our answers as I can. So immediately when I notice this, I usually like to start by writing everything as sine and cosine if I can. That's just kind of what I like to do. So if I'm going to take cosecant x, I can take cosecant x and write that as 1 over sine x. That's going to be all over cotangent x. Well, cotangent x is cosine x over sine x. So cotangent I put in green and cosecant I put in blue. Now, we're dividing with two fractions. Whenever we divide with two fractions, we don't. We multiply by the reciprocal. So I'm going to keep the top one the same, 1 over sine x, and I am going to multiply that by the reciprocal of the fraction on the bottom. So we're going to multiply that by sine x over cosine x. Well, when we are multiplying, we always like to reduce first. This sine x and that sine x are going to cross out. That will leave me with 1 over cosine x. And that's a good answer, but it's not as simple as it gets. Instead of saying 1 over cosine x, we're going to say secant of x. Boom. That's it. Let's try another one. Now, don't forget our algebra and our rules of equality. So I notice when I'm seeing these squares, I like to, whenever I've got a trig function and it's squared, I like to see if I can get any of them to equal 1. Well, I know if I take the sine squared x and I add a cosine squared x to that, we are going to get 1. So I am moving the sine squared x and the cosine squared x together. So we can say sine squared x plus cosine squared x is 1. And then I'm going to have 1 plus tangent squared x. Well, when we look back, we've got 1 plus tangent squared x. And for that, we can see 1 plus tangent squared x is the secant squared of x. Oops, I almost wrote theta, and we're doing x. My bad. Secant squared theta. Alrighty, so I'm going to go ahead and I'm going to stop the video right here. I'm going to continue on with example 2 and 3, 4, and 5 in another video. I thought it'd just be nicer to break the videos down into smaller groups. So we will see you in the next video.